All right, in this video, we're going to talk about part 3 of section 1.4 that deals with trigonometric functions and their inverses. This time, we're going to be looking at trigonometric identities. First, I'll just kind of briefly talk about what trigonometric identities are. Then we'll go into mainly the sum and difference identities, which I will discuss in this video. Also, we'll talk about how to solve trigonometric equations. Okay, so those are the only two we'll focus on here. All right, trigonometric functions have a variety of properties called identities that are true for all angles in the domain. And here's a list of some of the commonly used identities. And some of these I pretty much kind of touched on in the last video, which was part 2. But the tangent of theta will be equal to the sine over the cosine. Okay. Tangent theta is always going to be sine of theta over the cosine of theta. Now, cotangent of theta is the reciprocal of the tangent, as I mentioned in the last video. Cotangent theta will be 1 over the tangent of theta. And since tangent of theta is going to be sine of theta over the cosine of theta, cotangent of theta will be the reciprocal, which is cosine theta over the sine of theta. And then we have the cosecant of theta. That's the reciprocal of the sine of theta, 1 over sine of theta. And then secant of theta is reciprocal 1 over the cosine of theta. All right, the next 3 are what we call Pythagorean identities. This comes from the Pythagorean theorem that clearly states that if you have a squared plus b squared, that's c squared. The sum of the squares of the two legs is always going to be equal to c squared, which is the square of the hypotenuse. Okay, so here, one identity for this would be sine squared theta plus the cosine square of theta would be equal to 1. And also, if you divide each and every term by sine squared of theta, you'll get the next one. 1 plus the cotangent square of theta would be equal to the cosecant square of theta. And then if you multiply sine squared theta plus cosine square of theta equal to 1, divide each and every term by the cosine square of theta, you're going to get this identity. Tangent square of theta plus 1 equals secant square of theta. Okay, and now you have your double and your half angle formulas. I'm just going to introduce those to you because you'll pretty much see this when we go into other chapters in this course. Sine of 2 theta will be 2 sine theta times the cosine of theta. Okay, and also cosine 2 theta would be this, cosine squared theta minus sine squared theta. And the last 2 right here deal with cosine squared theta and sine squared theta. Cosine squared theta will be equal to 1 plus the cosine 2 theta. The whole thing is divided by 2. And sine squared theta will be 1 minus the cosine squared theta. Now, sine squared theta equals to 1 minus cosine 2 theta divided by 2. Okay. Now, we won't do any problems in this video that are related to double angle and half angle formulas, but do keep these in mind because you're going to see these when we do other problems like in chapter 2 and in chapter 3 and possibly chapter 4 in this course. Okay, and also you'll be using these as well, along with the other reciprocal identities and everything else that's talked about in section 1.4. All right, next we'll look at the sum and difference identities. Sum and difference identities. We're going to be doing problems using these here, these 6. Here, the cosine of alpha minus beta. That's going to expand as this. The cosine of alpha, which is the first angle, times the cosine of beta, that's going to be the second angle. And then if this is a minus with the cosine, it's going to change to the opposite sign, which is a plus. Sine alpha, sine beta. And as you can see here with the cosine of alpha plus beta, same thing here and here. The only difference here is their signs. If this is a plus, we make that a minus for those two. If this is a minus, we make it a plus. But for sine of alpha minus beta and sine of alpha plus beta, the signs stay the same. So sine of alpha minus beta would be sine of alpha cosine beta minus cosine alpha sine beta. And then sine of alpha plus beta, well, that's sine of alpha cosine beta plus cosine alpha sine of beta. And then these last two deal with the tangent of alpha plus beta and the tangent of alpha minus beta. This is what the tangent of alpha plus beta looks like. Tangent alpha plus the tangent beta in the numerator divided by 1 minus, here the opposite sign, tangent alpha times the tangent of beta. And then for tangent of alpha minus beta, the numerator, same thing, tangent of alpha minus tangent of beta. The denominator will be 1, instead of a minus, it'll be a plus, tangent alpha, tangent beta. Okay. So we're going to apply these sum and difference identities to these examples here. All right, like in part A, here we're going to use an identity to find the exact value of each expression. So here we're looking for the exact value. We're not looking for an approximate value. Like cosine of pi over 4 plus pi over 6. So here, if we look at this, this follows this format right here, cosine of alpha plus beta. So we're going to write it out like this, cosine of alpha, cosine beta, minus sine of alpha, sine of beta. So here, cosine of pi over 4 plus pi over 6 will be cosine of pi over 4 times the cosine of the second pi over 6. This time, instead of a plus, we're going to use a minus. Then sine of pi over 4, sine of pi over 6. Okay. Now, if you would like, you can use that unit circle that I gave you in one of the previous videos to find cosine of pi over 4, cosine pi over 6, sine pi over 4, and sine of pi over 6. So in this case here, pi over 4, let's find pi over 4, which is right here. Keep in mind that the x-coordinate is way up here. Keep in mind the x-coordinate is always the cosine. The y-coordinate is always the sine. So in this case, pi over 4, the cosine of pi over 4 is the square root of 2 over 2. And for pi over 6, which is here, its cosine is that x-coordinate, square root of 3 over 2. Then minus sine of pi over 4 and sine of pi over 6. Well, the sine is always the y-coordinate on the unit circle. So starting with the pi over 4, the y-coordinate for pi over 4 would be this one, square root of 2 over 2. Times sine of pi over 6. But here's pi over 6. The y-coordinate for pi over 6 will be 1/2. And now let's simplify this. I can multiply radical by radical as long as the indices are the same. So the square root of 2 times the square root of 3 will be the square root of 6 over 2 times 2, that's 4. And then minus The square root of 2 times 1 will be the square root of 2, all over 2 times 2, which will be 4. And since the denominators are the same, I can write that as the square root of 6 minus the square root of 2, all divided by 4. And that would be as far as I can go with that problem because I can't combine these two here. Just have to leave it as is. All right, so that's part A. Okay, part B. Cosine of 30 degrees minus 45 degrees. And here they're giving this to us in degree measure, but still we can use the identities here. Cosine of the first minus the second would be this format. Cosine alpha, cosine beta, plus sine alpha, sine beta. So I'm going to write that as the cosine of the first angle, which is 30 degrees, times the cosine of the second, that's 45 degrees. Change that minus to a plus, sine of the first, which is 30, times the sine of the second, that's 45 degrees. All right, so now let's find the cosine of 30 degrees. And of course, the x-coordinate, if we find 30 degrees, which is right here, the x-coordinate for the cosine, that's the square root of 3 over 2. Times the cosine of 45 degrees. There's 45 degrees right here. The y-coordinate, well, actually the x-coordinate for the 45 degree angle would be the square root of 3 over 2. So that's what cosine of 45 degrees will be, the square root of 2 over 2. And then plus, well, sine of 30, well, here's 30 degrees. The y-coordinate for that 30 degree angle is your sine, 1/2. So the sine of 30 degrees is 1/2 times the sine of 45 degrees. Let's see, here's 45 degrees right here. The y-coordinate for that 45 degree angle is what sine of 45 will be, the square root of 2 over 2. And now let's simplify this. Square root of 3 over 2 times the square root of 2 over 2. Square root of 3 times the square root of 2 will be the square root of 6 over 2 times 2, which is 4. And then plus 1 times the square root of 2 is the square root of 2 over 2 times 2, which is 4. Well, notice that the denominators are the same, so I can write that as the square root of 6 plus the square root of 2, all divided by 4. All right. Let's look at this one, sine of pi over 3 plus pi over 4. Now here we got the sine of the sum of the two angles, which is right here. So it's got to be written like this, sine of alpha cosine of beta plus cosine alpha sine of beta. So sine of pi thirds plus pi fourths is this, the sine of the first, which is pi thirds, then cosine of the second, that's pi fourths, and it's still going to be plus, the sign stays the same. If it's plus for the sine of the two, this has to be a plus. And then cosine of that first angle, pi thirds, sine of the second angle, pi fourths. And now we find the sine of pi thirds using our unit circle. All right, pi thirds is this, that's the 60-degree angle. The y-coordinate for that would be, of course, the square root of 3 over 2. Times cosine of pi over 4 is pi over 4. The x-coordinate for pi over 4 would be your cosine, square root of 3 over 2. I'm sorry, square root of 2 over 2 plus cosine of pi thirds. All right, here's pi thirds right here. The x coordinates for that would be the 1/2. That's your cosine of pi over 3. Times sine of pi fourths. Pi fourths is right here. The y coordinate for that would be square root of 2 over 2. Right, so now let's simplify this a bit. Numerator times numerator, the square root of 3 times the square root of 2 would be the square root of 6 over 2 times 2. That'll be 4. And then plus 1 times the square root of 2 will be the square root of 2 divided by 2 times 2. That will be 4. Here the denominators are the same, so I can simplify that as the square root of 6 plus the square root of 2. The whole thing will be divided by 4. Okay. All right, and there is one more of these on the next page. This time it deals with the tangent of pi fourths plus 2 pi thirds. Tangent of pi fourths plus 2 pi thirds. Well, that follows this rule right here, this identity. Tangent of alpha plus beta. We have to write it like this. Tangent alpha plus the tangent beta, whole thing divided by 1 minus tangent alpha, tangent beta. So this means the numerator will be the tangent of the first, that's pi fourths, plus the tangent of the second, that'll be 2 pi thirds. And that's divided by 1. The opposite of plus will be minus the tangent of pi fourths, the tangent of 2 pi thirds. Now, if we use that unit circle, we have to know this, that the tangent of some angle theta would be equal to y over x. That's something we need to know. So if we look for pi over 4, it's pi over 4 right here. The y coordinate is the square root of 2 over 2. The x coordinate is also the square root of 2 over 2. Okay. So for tangent of pi fourths, the y coordinate was the square root of 2 over 2. The denominator, the x was the square root of 2 over 2. Well, the square root of 2 over 2 divided by itself is automatically going to be 1. So we can see that the tangent of pi fourths will be 1. Now for the tangent of 2 pi thirds, that's again going to be the y coordinate divided by the x coordinate. All right, so for 2 pi thirds on the unit circle is 2 pi thirds here. The y coordinate is the square root of 3 over 2. The x coordinate is negative 1/2. So that means if I do the square root of 3 over 2 divided by negative 1/2, I can do this, divide the numerator and the denominator by 2. That would mean that these 2's in the numerator right here divide out, and then the denominator, that the 2 divides out. I don't know what I'm trying to say. So this will be the square root of 3 over negative 1. That's going to be negative square root of 3. That's what tangent of 2 pi thirds will be. So let's go ahead and fill this in. Tangent of pi fourths will be 1 minus Tangent of 2 pi thirds, plus. Tangent of 2 pi thirds will be negative square root of 3. All divided by 1 minus. Tangent of pi fourths will be 1. And the tangent of 2 pi thirds is negative square root of 3. All right, so let me simplify this numerator. I can rewrite that as 1 minus the square root of 3. The denominator will be 1, and then that minus times the negative will make that a plus square root of 3. Now, I'm sure they're going to want this simplified. So that means we're going to have to do something called rationalizing the denominator. Okay. When we rationalize that denominator, what we do here is multiply the numerator and the denominator by what they call the conjugate. So in the denominator, the conjugate of 1 plus the square root of 3 is this. We keep the same terms, but we change this symbol to the opposite. Since it's a plus, it would be minus. So the conjugate would be 1 minus square root of 3. And had that been 1 minus square root of 3, its conjugate would be 1 plus the square root of 3. So we're going to be multiplying the numerator and the denominator by its complex conjugate. 1 minus, well, not complex conjugate, by the conjugate. So it'll be 1 minus the square root of 3. And what's going to happen here is this. I need to use the FOIL method in the numerator here, like this. First term times the first term. 1 times 1 will be 1. Outer is 1 times minus square root of 3, which will be minus square root of 3. The inner minus square root of 3 times 1 will be minus square root of 3. And then minus times a minus will make that a plus. The square root of 3 times itself, that will wipe out the radical and you'll be left with what's underneath it. Because the square root of 3 times the square root of 3 will be the square root of 9. But the square root of 9 is 3. So you can think of it like that. Now the denominator, since these are conjugates of each other, I can just simply square the first term minus the square of the last term. The square of 1 will be 1. The square of the square root of 3. If you square a square root, the radical is gone. You'll be left with what's underneath it. It'll be 3. Now let's simplify this. Combining like terms, I got 1 plus 3, which is 4, minus square root of 3 and another minus square root of 3. For how many square roots of 3 do I have? That would be 2. So it'd be 4 minus 2 square root of 3, and then 1 minus 3 will be negative 2. Now what I can do is divide each and every term in the numerator by negative 2. Here 4 divided by negative 2 is negative 2. Negative 2 square roots of 3 divided by negative 2 will just leave me with a plus square root of 3. So in this case here, my final answer there will be negative 2 plus square root of 3. Okay, now in example 6, let's say I want to simplify each expression using appropriate identities here. Now here is written out like this. We're going to be going backwards to come up with our answer. So here, let's say we have sine of 56 plus the cosine of 34 degrees plus cosine of 56 sine of 34 degrees. So now we have to look at this right here. Because we got sine of 56 cosine of 34. And then we got plus cosine and then sine. This is similar to that right here. So that means this must be equal to the sine of alpha plus beta. Okay. So you have to pick which one of these match what you have here. When you expand this, is you got sine times the cosine, and then a plus cosine times the sine. That has to be this right here, sine of alpha plus beta. So that means I can write that as the sine of 56 plus 34. And that should be 56 degrees plus 34 degrees. All right, so if I add 56 degrees and 34 degrees, I would get 90 degrees. So I want to find out what the sine of 90 degrees is. Well, by looking at this unit circle, 90 degrees is right here. The y-coordinate is what sine of 90 degrees will be in this case, which is actually 1. So sine of 90 degrees is 1. All right, part B. Sine of 75 degrees, cosine of 75 degrees, minus cosine 75 degrees, sine of 15 degrees. Going back to these sum and difference identities, we have the sine times the cosine, and then minus cosine times the sine. Has to be this right here, sine of alpha minus beta. Has to be. So this will be sine of 75 minus 15 degrees. And 75 degrees minus 15 degrees will be 60 degrees. So I'm finding what the sine of 60 degrees will be. Using the unit table or the unit circle, here's 60 degrees. The y-coordinate is your sine. So sine of 60 degrees is this right here, square root of 3 over 2. Okay. And now part C, we have tangent of pi 12ths plus the tangent of pi 4ths, all divided by 1 minus the tangent of pi 12ths times tangent of pi 4ths. In this case, let's look at what we have here. It's got to be one of these two here, because all you see there is tangent. That's all you see. But notice in the denominator, we got 1 minus tangent of alpha plus the tangent of beta. But here we got the same thing, 1 minus tangent pi 12ths times tangent pi 4ths. That's this right here, which is going to be this right here, tangent of alpha plus beta. Okay. So this can be written as the tangent of pi 12ths plus pi 4ths. Okay. Now I'm going to use my graphing calculator to come up with a fraction for that. Okay. Let's see, pi 12ths is like 1 divided by 12 plus, now I'm going to put the 1 divided by 4 in parentheses. And then press the math key and select number 1 for fraction. And that will end up being 1/3. But since I got the pi there, it'll be 1/3 pi, or pi over 3. So it'll be the tangent of pi over 3. And if you recall, the tangent of any angle theta, if we use the unit circle, it's going to be y divided by x. That's the y-coordinate divided by the x-coordinate for that angle. So the angle we're dealing with is pi 3rds right here. The y-coordinate for that was the square root of 3 over 2 over the x-coordinate, which is, in this case, 1/2. Okay, so we've got the square root of 3 over 2 divided by 1/2. And of course, when you divide fractions like the square root of 3/2, we multiply by the reciprocal of this fraction in the denominator. 1/2 is reciprocal is going to be 2/1. You're going to see that these 2's divide out. So you're left with the square root of 3/1, which will simplify as the square root of 3. And so that's how we use the sum and difference identities to simplify expressions. Okay, next we'll look at how to solve trigonometric equations. Now, there are some algebraic methods and trig identities that can be used to find the solutions of trigonometric equations. Okay, now, let's skip this example. So I'm going to omit this. But I am going to start with part B, which is this: sine of 2x equal to 2 times the square root of 2. And here I want to find out what x is going to be. Okay. Now the restriction here is from 0 to 2 pi. That means I want to find values of x between 0 and 2 pi so that the sine of 2x will give me the square root of 2x. All right, this would work if I had just the sine of x. The problem here is I get 2x. All right, so let's look at this restriction here from 0 to 2 pi. And we're excluding 2 pi's, which is why you see the less than there. If I want this x to be 2x, what I need to do here is multiply each side of this inequality by 2. Because notice I got sine of 2x, not sine of x. So my domain this time will be 2 times 0, that's 0, less than or equal to 2x, and less than 2 times 2 pi will be 4 pi. So I need to look for x values between 0 and 4 pi, where the sine of 2x will be the square root of 2/2. Okay. So let's look here for 2x, find out what 2x is and what 2x is in this case, between 0 and 2 pi. All right, now we can use this unit table. The sine has to be the y coordinate. So we need to select ordered pairs that have the y coordinate of the square root of 2/2. Well, here's one right here. That y coordinate is the square root of 2/2. And if you look here, this point has a y coordinate of the square root of 2/2. So there are 2 places here between 0 and 2 pi on this unit circle where we have for a y coordinate as the square root of 2/2, which represents the sine of 2x. Well, let's find out what those values are going to be. Here, this happens at 45 degrees or pi/4. It also happens here at this angle measurement, 3 pi/4. So I got 2 values of x, 2 values of 2x, where the sine of 2x will be the square root of 2/2. One would be at pi/4, the other one would be at 3/4, 3 pi/4. Okay. So again, we find the y coordinate with the square root of 2/2 in it. And it's at these 2 places right here. This occurs at pi/4 and this occurs at 3 pi/4. Now we're going to find out what x is. It's being multiplied by 2. Normally we would divide both sides by 2, but we got a fraction here. So let's multiply both sides by the reciprocal of 2. That's going to be 1/2. Oops. That should be pi/4 times 1/2. So that means x will be equal to, in this case, pi times 1 will be pi over 8. And then for 2x equal to 3 pi fourths, we'll multiply both sides by 1/2 as well. So that means x is equal to 1 times 3 pi would be 3 pi over 2 times 4, which is 8. And also something else we can do here. Since this is from 0 to 4 pi, that means we can add another 2 pi here. Since 2x is equal to pi over 4, we can also do this, add another 2 pi, and then for 3 pi fourths, we can add another 2 pi. So here, pi halves plus 2 pi. Okay, now this helps. You can do 1 divided by 2 plus 2. When I'm getting pi halves, it should be pi over 4. 4 comes from right here. So 1/4 plus 2, and then the math key fraction, that'd be 9/4, or 9 pi over 4. And then for 3 pi fourths plus 2 pi, 3 divided by 4. 3 divided by 4 plus 2, math fraction, 11 pi over 4. So there are actually more places where between 0 and 4 pi, where you get the sign of 2x equal to the square root of 2 over 2. Okay. So we can say 2x again, this time would be 9 pi over 4. And then multiply both sides by 1/2 to solve for x. And that's going to be x is equal to 9 pi over 8. And then for 2x is equal to, what's the other one, 11 pi over 4? We multiply both sides by 1/2. So that means x is equal to 11 pi over 8. Okay. And the reason why I had to add 2 pi here for the pi fourths and for 3 pi fourths, because of this restriction here between 0 and 4 pi. All right, so these are all the values of x, where sine of 2x would be equal to the square root of 2 over 2, with the restriction that x is between 0 and 2 pi. So here they are, pi over 8, 3 pi over 8, 9 pi over 8, and 11 pi over 8. Okay, now let's look at the next example here. Now here we want to solve the equation on the interval from 0 to 2 pi. So they give you that restriction here. Here we got 12 cosine square of x is equal to 3. And here we just have plain x. So our restriction is going to be like this anyway, because that's pretty much saying that 0 has to be less than or equal to x and strictly less than 2 pi. And we've already got the x here. All right. So I'll go ahead and rewrite this equation. 12 cosine squared x is equal to 3. Now I'm going to get cosine squared x by itself. What I need to do there is divide both sides of this equation by 12. So that means I'm going to have cosine square of x is equal to 3 over 12 reduces to 1/4. And now to get cosine x by itself, it's being squared. So the opposite of squaring something means you need to take the square root on both sides. This time, I'm going to include that plus or minus symbol. Anytime you take the square root on both sides of an equation, you must include that plus or minus symbol. So the square root of cosine square x is just simply cosine x, equaling to plus or minus the square root of the numerator and the square root of the denominator. The square root of 1 is 1 over the square root of 4, that'll be 2. So I got cosine of x is equal to plus or minus 1/2. What that means here is this. I need to know where cosine of x will be equal to 1/2. And I also need to know where cosine of x will be equal to negative 1/2. Let's start with cosine of x is equal to 1/2, using that unit table. Okay. This means I need to find out, now cosine of x, well, cosine is your x coordinate. I need to find out what x coordinates have positive 1/2 in it. Which of these ordered pairs have 1/2 as the x coordinate? Well, notice right here, and also if I bring this down a bit, it's also right here as well. At these two places, my x coordinate is 1/2. And what would be the angles where the cosine of x be equal to 1/2? Up here, that angle would be pi over 3. And down here where I have 1/2 as the x coordinate, the other x value will be 5 pi over 3. So I get two x values where the cosine of x will be equal to 1/2. It'll be at pi thirds. The other one will be 5 pi thirds. Okay. I also need the x values where the cosine of x is equal to 1/2. I mean negative 1/2. So I need to find out on this unit circle, the ordered pairs for x, which ordered pair has the x coordinate of negative 1/2? Well, this one does, and this one does up here. For this negative 1/2, that angle is 120 degrees, or in radians, 2 pi thirds. But this negative 1/2, this angle measured will be 4 pi thirds. Everyone see that? Okay, negative 1/2, that'll be 2 pi thirds. Negative 1/2 down here is also 4 pi thirds. So 2 pi thirds here and 4 pi thirds. So these are the values of x that will satisfy this equation, 12 cosine square of x equaling to 3. Okay. All right, and part D. Solve the equation on the interval 0, less than or equal to theta, and less than 2 pi. So theta has to be something between 0 and 2 pi. So in this case here, we got 12 sine square of theta minus 9 is equal to 0. Just rewriting the equation. Now I need to get the sine square of theta by itself. I'm subtracting 9, so I need to add 9 to both sides. So that means I got 12 sine square of theta is equal to 9. And then to get sine squared theta by itself, I'm multiplying it by 12. I need to divide both sides by 12. So that means I have sine squared theta is equal to 9 over 12 will reduce to 3/4. And then finally, I'm squaring the sine of theta. The opposite of that would be to take the square root on both sides. And I must include that plus or minus here when I take the square root on both sides. So the square root of sine square of theta would be just sine of theta. And then that's equal to plus or minus. I'm not going to be able to take the square root of 3. So that stays underneath the radical. However, the square root of 4 is 2. So sine of theta would be equal to plus or minus the square root of 3 over 2. So I need all values of theta where the sine of theta would be positive square root of 3 over 2. I also need all values of theta between 0 and 2 pi, where the sine of theta will be equal to negative square root of 3 over 2. Okay, let's start with the sine of theta equaling to the square root of 3 over 2. I know that sine is the y-coordinate on the unit square. So I need to find out what points have the y-coordinates of the square root of 3 over 2. Right here and right here. Here's square root of 3 over 2 and here's square root of 3 over 2 as their y-coordinates. That means for this one, that angle has to be pi thirds. And for this one up here, that angle is 2 pi thirds. So got pi thirds and 2 pi thirds, where the sine of theta would be the square root of 3 over 2. Now, what about for sine theta be equaling to negative square root of 3 over 2? Now, I need to find out from that unit circle, which of these points have the y-coordinate of negative square root of 3 over 2. It's these two at the bottom right here. The y-coordinates at negative square root of 3 over 2 here and here. For this one, that angle was 4 pi thirds. And for this one, that angle is 5 pi thirds. So at 4 pi thirds and 5 pi thirds, the sine of theta will be negative square root of 3 over 2. Okay, so these are all the values of theta that satisfy that trig equation. Okay. All right, so that will conclude this video of part 3 of section 1.4, dealing with trigonometric functions and their inverses. All right, please feel free to email me or contact me if you have any questions or any concerns about what's in this video and the homework for part 3 of section 1.4 in my math lab.